It makes the rocks this way, right? Is there a way to put a fixed amount of here? Put some rocks here.
Really close to
You already take some, maybe. You already have more rocks, you know? Could you distribute the rocks? I don't know what's going to happen, but just
a little bit of air out of it.
Overall, I think you're finding out that water's not going to do it. Water in water is just going to be the same density, maybe a little bit more, so you might be in that halfway point where you're not sinking all the way and you're not floating. What do you need? You need mass. So like Brooklyn was saying, you need to maybe come up with some things around the house that might weigh more than 1 gram that's going to cause your submarine to sink. I think we all thought, like, how are we going to make this thing float? I think we're having the problem of how we're going to make it sink. So you have one more day, which is tomorrow, to make sure that this is a working submarine, and then Friday our presentations. So here's where I want everything to go. Okay, your submarine, if the water, do you see like right here is where her tube is? There's a hole right here. If your water is above the hole, you need to go dump the water out until it's not, because that's how we had that leak over there. Okay? Then you can put more water in it yesterday. So they should be okay because their water is underneath the hole line. Okay? Everything needs to go in your folders. Put your folders in the center of the table and your calculators up.
She said it's already in there.
How you make it a
The way that I put the thing in water because the top's going to up from the ground. That's pouring out like water up there.
And so I asked if you need help.
Hey, whose jacket is this?
That is a nice
No, like the balloon.
that might be. Yeah.
Looks like it's leaking and blowing it out. Somehow maybe that fitting
Go ahead and try it.
Hold it up.
You know we're not going to be able to do it.
Yeah, well, she's going to drop them.
Ready?
It's gonna work.
No, we have too much. Oh, yeah.
He's trying to be hover, but it's leaking. It's leaking somewhere.
It's called hammer.
Yeah, it's leaking right here.
Smack them into it.
Wow! That's been the most successful one I've seen today.
We got a leak in the straw.
That is
So, hey, so once you get all 3, you are going to average them. You add them up and divide by 3. That's going to be your velocity, okay? Once you have your velocity, you're going to write an equation. Y equals mx plus b. Your m is going to be your velocity. Your b is your initial value, which is what? Where are you starting at? 0. Okay? All right, then you're going to take the 2, you're going to set them equal to each other, and you're going to find an intersection point. I need this entire paper filled out by every single one of you, okay? This is what you're getting graded on. This is 10% of your grade, this piece right here. So as soon as you get your time trials done, you're done working on your prototype. You can't work on it anymore. The reason is because once you time it, you can't make any more adjustments to it because that will mess up the prediction time because we're actually going to test it to see if you were correct in the prediction. Okay? So then you're going to have to do your graph and you're going to have to check it algebraically. Here's what I would do, Jordan. I would check it algebraically first. I would set the 2 equal to each other and I would see what the intersection point is first, then I would graph it so that you know what to make your scale. A common problem today that I've been seeing, people have been making their graphs like if this is time right here, and this is distance, people have been making their distance like -10, -15. Does the graph go up into negatives? No. No, your graph needs to go down. So that you I would probably go by 5s. Okay? So you're going to have a line that kind of looks like this, and you're going to kind of have a line that looks like this. You're looking for this intersection point. When you find that intersection point, and you write it as a point, look what the last class did. I'm going to have a note up here. You need to come up here and you need to write down what your predicted time is, because that's the time you're using for presentations today. Does that make sense? So that's what you have to do. No one's up here testing it anymore. I'm up here doing time trials. Okay? So once you get your time trials, you're just sitting down quietly and you're getting your packet done. Okay? Okay. Ready, set, go. Okay. Oh, it wouldn't stop, but it was 0.5. Let's do another one since it wouldn't stop. This is good. On the last one, can we go up this number? On the last one, yeah. Ready, set, go. 0.6. Oh my gosh. Just 0.6. You have 1.6. Okay, and then go ahead and bring it back up manually. Okay, last time. Ready, set, go. 0.6. So what you guys are going to do now is you're going to take your distance, -24, divided by all 3 of your times that you have. You're going to take the average of it. Okay, that's going to help you make your prediction. Now you can see if it comes up.
You're pausing now.